Hello, students. Remember, you are going to be quizzed on this, so if you just copy the answers down, you're probably going to be a little bit stuck later on, and the quiz is what's really going to count, okay? All right, if you're the student controlling the iPad, if you could push the pause button for 1 minute, and everyone can check their work. All right, I'm going to show two different methods for problem number 1. So the first method, I'm going to call it the GCF method. We have 27 out of 72. The GCF method basically asks us to find the biggest factor, the greatest common factor that can divide into 27 and also divide into 72. It does save us some time. The biggest number I can think of is 9, so I'm going to divide the numerator and the denominator by 9 because 9 can divide both of them evenly. 27 divided by 9 is equal to 3. 72 divided by 9 is equal to 8, and that's how you do the GCF method. The issue is that if we're not used to factoring, it can be difficult to figure out what number divides both of them and why, is it the biggest number? So that's why we use the factor tree method. It takes a little bit longer, but it's also something that's very doable for all those that put the time into it. So the way that works, I'm going to do the same thing, 27 over 72, okay? And I'm going to factor both of these with my factor tree. 27, that's just 3 times 9. 3 is prime. You can look at the poster at the back of the class by the cabinets, and you can see that. It's highlighted red and yellow. That means that you cannot divide it anymore because it's a prime number without you'll turn it into a decimal if you do. 9 is just, hopefully you guys said 3 times 3. That's why I paused. Anyways, and now the way that we're going to do this is we're going to go ahead and make our list. Okay, so if I have 27 over 72, that's equal to 3 times 3 for 27. 3 times 3 is going to give me 9. Multiply times 3, I'm going to get 27. Now we're going to break it down for 72. That's just 8 times 9. Okay? Then you can break 9 down. You can go 3 times 3, and those are prime. 8, that's not a prime number. If you look back on the list, it's not highlighted red and yellow, so that can be broken down further into 4 times 2. 2 is prime. 4 can be broken down into 2 times 2. So now we're going to organize that. 72 is just 2 times 2 times 2, which gives you 8, times 3 times 3, which gives you 9. So 8 times 9. All right. Now's my favorite part, cross-canceling. Okay, the 3's cannot cancel with any of the 2's. However, this 3 on top can cancel with this 3 on the bottom. And this 3 in the numerator on top can cancel with this 3 in the denominator on bottom. And now we have what's left over, 3 in the numerator and 2 times 2 times 2 in the denominator. Well, 2 times 2 is 4 times 2 is 8. So that gives me 3 on the top and 8 on the bottom. Takes longer, but everybody can use the factor tree if you use your multiplication chart. And you know when a number is prime by looking at the poster in the back of the room. If you cannot factor, then use the factor tree. There's no other way to do it if you can't do the GCF. If I'm wrong, let me know. Share with your friends, and we can learn a new skill together. All right, guys. Next one, I'm going to use the same strategy. We're going to do the GCF method for greatest common factor, and then we're going to do the factor tree method. Let's take a look at number 6. Okay, if I have 20 45ths. The biggest number that I can think of that goes into both of those is 5. So I'm going to divide the numerator and the denominator by 5. 20 divided by 5 gives me 4. 45 divided by 5 gives me 9. Now, if you find that it can be divided further, then you can just do one more step. But the GCF method, it's a little bit shorter than the other way. Sometimes you got to throw an extra step in there, okay? Now, if you're not a GCF kind of person, greatest kind of factor person, then again, use the factor tree. We have 20 and 45. I am going to go through this pretty quickly, but just to kind of demonstrate. 20, you could go 4 times 5, you can go 2 times 10, doesn't really matter. You're going to get the same result either way. I'm going to go 2 times 10. Okay? Now, I know that the 2's are prime because we look at our poster, and it's red and yellow up there. 5 is prime, same reason. Okay, use your resources. All right, now we got 45. That's 5 times 9. You can break that down, 3 times 3. Okay, now the way we're going to break this down using the factor tree is I have, that for my 20, it's 2 times 2, which is 4. Multiply 4 times 5, get 20. All right, for 45, I'm going to go 3 times 3 gives me 9, and 9 times 5 gives me 45. I cannot divide 2 with 3 without turning it into a decimal, but 5 divided by 5 is 1. So this is what's left over. So I'm going to highlight this, guys. Whenever this happens, it doesn't mean you can't solve it. It just means remultiply it. 2 times 2 will give you 4. 3 times 3 will give us 9. So 4/9 is what we get. Same thing for both methods, right? Now here's the thing. People are going to ask, why on earth would you use the factor tree method when the GCF method is much quicker? Well, if you can use the GCF method, then go ahead and use it. But if for the life of you, you're like, where on earth did this 5 come from? Well, the factor tree method's probably for you, okay? Eventually you'll recognize these numbers a little more and go back to the GCF method. Have a good day, class.